Hi everyone, this is Jesse here from SkyCiv, and today we're going to be talking about the difference between ultimate bearing capacity, allowable bearing capacity, and design bearing capacity. So I have the bearing capacity tool open here, and I'm just going to run this so we can look in our report and see the different headings here and what they mean. So first of all, we have the ultimate bearing capacity, which gets calculated as 144 kPa. Now, this capacity doesn't consider any factors of safety, which is why it has the term ultimate. Typically, it's denoted with the U. So here we have the value QU, 144 kPa. And this is not something we'd use in design because it hasn't incorporated any factors of safety. If we're using a factor of safety or an allowable strength design-based approach, what we will do is we'll divide this by our factor of safety to get our allowable bearing capacity. So in this example here, we can see we're just dividing by our factor of safety of 3 to get a bearing capacity of around 50 kPa, an allowable bearing capacity that is of around 50 kPa. And we can then compare this to our working loads. So in this design here, we've input a 100 kilonewton load, dividing that by our 2 meters squared area to get 50 kPa, which is slightly greater than our 48 kPa allowable bearing capacity. On the other hand, if we're not using a factor of safety or allowable strength design-based approach, and we're using the Eurocode or the Australian standard, we might be using a partial factor of safety design method, which is what the Eurocode uses, or a load and resistance factor design method, which is what the Australian standard uses. Now, for both of these methods, I'm going to run this, we'll see. For both of these methods, we have load factors that get used where we factor up the design loads. So from 100 kilonewtons, we've gone to 135 kilonewtons for the shear limit state, which is what the Eurocode uses in assessing bearing capacity. The Australian standard is quite similar in its LIFD approach, where we also increase the loads with some load factors. That's for the strength limit state in the Australian standard. And then for these methods, we also have reductions, which we may apply to the material properties. In this case, those reductions aren't applied to the material properties, or we might apply the reductions just to the bearing capacity that we calculate. So in this design approach, DA2 of the Eurocode, that's the way it's done. We have the bearing partial factor of 1.4 and no partial factors for the materials, but it could also be partial factors on the materials. And then when we do our calculations, we can see, yes, we can calculate the ultimate bearing capacity of 144 kPa, the same as what we calculated before. But now instead of dividing by a factor of safety of 3, we're going to divide by our partial reduction factor of 1.4. We're going to get a bearing capacity of 100 kPa, a design bearing capacity. And now instead of comparing to a working load, we're going to be comparing to a factored design load. So that's the main difference between design bearing capacity and allowable bearing capacity. With design, we're comparing to a factored working load. With allowable, we're comparing to a working load. So on site, a lot of the times an allowable bearing capacity might be specified. So if we ever need to convert our design bearing capacity into an allowable bearing capacity, because we don't necessarily know what like how much of the load on site is going to be dead or live loads, we're going to have to be conservative. And if we ever wanted to convert this to an allowable bearing capacity, we'd have to divide by the maximum possible factor that might be applied to this. So for example, here we can see we have load factors of 1.35 or 1.5. So in this case, we'd need to divide this by 1.5 if you wanted to specify this as an allowable bearing capacity. So that's the main difference between the ultimate, design, and allowable bearing capacity. I hope this was clear and helped. If you want to leave us any questions or have any feedback for this video, you can leave us a message here. Otherwise, I recommend to play around with this tool, and you can continue to watch the videos in this series for more information on the bearing capacity. Thank you. Bye.